So hello guys, we've learned different types of reactions in this chapter. They include synthesis reactions, combustion reactions, decomposition reactions, double decomposition reactions, displacement reactions, reversible reactions, and catalytic reactions. In this quest, we will be discussing another type of reaction called redox reactions. However, we cannot discuss redox reactions without learning of the individual reactions that make up redox reactions: reduction and oxidation. We will look at three definitions of oxidation and reduction based on three different criteria. We will start with the definition based on oxygen transfer. Now, based on oxygen transfer, oxidation is the addition of oxygen to a substance, while reduction is the removal of oxygen from a substance. What this means is that if I add oxygen to an atom of sodium to form sodium oxide, then I can say that sodium has been oxidized to sodium oxide. This is because oxygen has been added to sodium. Also, if we have a chemical reaction between iron 3 oxide and carbon in the form of red hot coke to form pure iron metal and carbon 4 oxide gas, then we can say that iron 3 oxide is reduced because it has lost oxygen, while carbon is oxidized because oxygen has been added to it. Reduction and oxidation can also be defined based on hydrogen transfer. Based on this criterion, oxidation is the removal of hydrogen from a substance, while reduction is the addition of hydrogen to a substance. So, in a reaction between ammonia and bromine to produce nitrogen gas and hydrogen bromide, we can agree that ammonia is oxidized because it has lost hydrogen, while bromine is reduced because it has gained hydrogen. Another definition of reduction and oxidation is based on the addition of electropositive and electronegative elements. On this ground, reduction involves the addition of electropositive elements to a substance, while oxidation involves the addition of electronegative elements to a substance. In the reaction between sodium and chlorine to form sodium chloride, because the sodium atom has an electronegative atom of chlorine added to it, we can say that sodium has been oxidized. While since the chlorine atom had an electropositive atom of sodium added to it, we can say that chlorine has been reduced. Knowing these three definitions, we now know how to identify a redox reaction. A redox reaction is a reaction where reduction and oxidation occurs at the same time, that is, simultaneously. As a matter of fact, whenever a species in a reaction undergoes oxidation, the other must be reduced in the process. With this in mind, let's try to identify the reduction and oxidation half equation in these reactions. From the first question, because an electronegative element, fluorine, is added to sodium chloride, then it means that sodium chloride is oxidized while fluorine is reduced. For the second question, hydrogen is added to oxygen, and that represents a reduction of oxygen, while oxygen being added to hydrogen indicates an oxidation of hydrogen. I believe that you can now define redox reactions based on oxygen transfer, hydrogen transfer, and the transfer of electronegative and electropositive elements. In case you've forgotten, based on oxygen transfer, oxidation is the addition of oxygen to a substance, while reduction is the removal of oxygen from a substance. Based on hydrogen transfer, oxidation is the removal of hydrogen from a substance, while reduction is the addition of hydrogen to a substance. Lastly, based on the addition of electropositive and electronegative elements, Oxidation involves the addition of electronegative elements to a substance, while reduction involves the addition of electropositive elements to a substance. Catch you guys in the next lesson.